Have you considered using HPLC for skin sensitization testing? A skin sensitization test is a test to evaluate the allergic reactivity of skin to certain chemical substances. To promote animal welfare, alternatives to animal testing are being developed. DUPRA, ADRA and K-DUPRA are currently listed as alternative methods in OECD DG 442C. The OECD Testing Guidelines is a collection of international guidelines for chemical hazard evaluation. These three non-animal methods utilize the fact that, in the early stages of skin sensitization, chemical substances induce an inflammatory response when they bind to cysteine and lysine in epidermal proteins. In this video, we introduce the method known as amino acid derivative reactivity assay, ADRA. ADRA evaluates the binding characteristics of test substances using NAC or NAL. NAC and NAL are synthesized by inducing cysteine and lysine, respectively, to bind with naphthalene rings. ADRA offers advantages over DUPRA. For example, it enables analysis at 1% concentration and detection at 281 nanometers, a wavelength which is relatively insusceptible to impurities. In the skin sensitization evaluation, there are set testing conditions, for example the linearity of the standard calibration curve and the system stability check using a reference control. A proficiency test is also provided to assess the test environment and the technical proficiency of the tester. We use the Nexera XR to perform these evaluations for this application news. High-speed analysis conditions were also evaluated. For the reagent, we use this ADRA kit from Fujifilm Wako Chemicals. For the pretreatment, pour NAC, NAL solution and reagent solution into a 96 well microplate and mix. Incubate at 25 degrees Celsius for 24 hours. After incubation, add the stop solution and set the plate in the autosampler rack. With lab solutions, it's simple to create an analysis schedule. This schedule is used to start the analysis. Now let's take a look at the results. In the linearity evaluation of the calibration curve, R² should be greater than 0.99. Good results were obtained for both NAC and NAL components. The results of the system suitability check using the reference control also satisfied the specified conditions. The system suitability check consists of three different controls. Reference control A verifies that NAC and NAL are at the specified concentrations. For reference control B, the analysis is repeated 3 times both before and after the sequential analysis of the test sample. This confirms system stability during the analysis period. Reference control C is used to determine the reactivity of NAC and NAL with the solvent used for each test sample and to calculate the percentage reduction in NAC and NAL. The reduction rates of NAC and NAL were calculated for 10 evaluation compounds listed in the OECD. This is the equation for the reduction rate. The technical proficiency evaluation is passed if the reduction in NAC and NAL are within the prescribed reduction rates for the given substance. In addition, the standard deviation should be 10% or less when the analysis is repeated 3 times. For the system suitability check, standard values should be met for at least 8 out of 10 evaluation compounds. In this case, all 10 compounds met the criteria. We also tried a higher speed analysis using a column recommended by the OECD. The calibration curve linearity was comparable to the linearity under OECD conditions, and the analysis time was reduced from 20 minutes to 7 minutes. For accurate and rapid ADRA with the Nexera Series, see the application news for more details.